Fellow geometers and seekers of truth, we will look at another example here of finding the area of a sector. Okay, so the sector is a region that's bounded by an arc and the two radii. So let's look at this example. The radius of the circle is 7 centimeters. Find the area of the shaded region. So I'm going to shade this in a little bit more dark so you can see it better. So you have this arc right here, this region right here, and this angle here is 90 degrees. Okay, and because that is a 90-degree angle, this, and again, let me shade this a little better. This shaded region right here, okay, this shaded region is 1/4 of the circle, right? 1/4 of the entire circle. So if we can find the area of the entire circle, then we could just multiply that by 1/4. And so if you recall, the formula for area of a circle is pi times the radius squared, which is equal to pi times 7 in this case, squared, which gives us 49 pi. And I don't need to figure out what this is exactly for the time being. We'll use that a little bit later. If we need to multiply this out in round, we can do so. So now we can answer our question. That means the shaded region. In other words, we call that region there a sector, is equal to 49 pi times 1/4. And again, if we need to get the exact answer, we can certainly do that. And this gives us an answer of 38.485. Okay, so, and of course, this is an approximation because with pi, we're never going to get 38.485. And our units here are in centimeters squared. And so now what I like to do is extend this idea to something a little bit more complicated. In this case, it was nice that we had a 90-degree angle here, but what if it wasn't 90 degrees? Okay, well, there is, rest assured, there is still a way that we could figure. All right, so we had a formula earlier for arc length, and now let's talk about the formula for the sector area. So given a circle with a radius r and an arc AB, then we can say almost the same thing as we did before, almost. The measure of the arc AB over 360 degrees is equal to the sector area, and that's the region bounded by the arc and the radii. So just to be clear, when I say the sector, okay, so this is the sector formed by AB over the area of the circle. And I like to take this one step further. We can say the measure of the arc over 360 degrees is equal to, and I'll just abbreviate this, sector area over the area of the circle, which in our case is pi r squared. Okay? So this is a formula that we could use to calculate the area of any sector. And so now what I like to do is go back and solve the previous problem we had here, a slightly different way. Right? Rather than rely on the fact that it's 1/4, let's just use the formula that we had here. So the measure of the arc here is 90 degrees over 360. That's equal to the sector area. I guess we'll just call this area here x over pi r squared. And you'll see why we get the same thing. The radius in this case is 7. So you see here that on the left side, 90 over 360 reduces to 1/4. On the right side, we get x, and in the denominator, we get 49 pi. So now, multiplying both sides by 49 pi, We were able to eliminate what's on the left, and on the right, we end up with 49 pi times 1/4 again, which is equal to x, which is equal to this result here. So you see here that when I said earlier that this region is 1/4 of the circle, the 1/4 really comes from 90 degrees over 360 degrees. For a more general formula, we want to use this one. Even this formula down here works even if the measure is not a nice number like 90, even if it's 73, 81, anything like that. This process here still works. As always, thank you for watching. Keep working hard and